Figures 4.9 through 4.11, Gradebook, Calculating the Class Average with Sentinel-Controlled Repetition. In this example, we're going to revisit the gradebook once again, and specifically we're going to look at a new implementation of the determine class average member function. Now, if you look at the header file here, you'll see that it's identical to the one that we had in the previous video. And also, if you look at the main function, you'll see that it's identical to the one in the previous video as well. So the only thing that's actually changed is how we're determining the class average. And in this case, we're going to determine the class average using Sentinel controlled repetition. And basically, that's going to enable us to enter any number of grades. And we're also going to have a couple of other changes as well. For example, in this version, we're going to use floating point numbers to actually calculate the class average. So let's run this program. And here we see that we're prompted after the welcome message is displayed to enter a grade or -1 to quit. Now, if I enter -1 as the first grade, it tells me no grades were entered and it does not calculate a class average. On the other hand, running it again, if I enter 10, or actually any number of grades, so let's just do 3 grades for example. So let's do 100, 95, and 92. And I'll do -1 to quit, and I see that my total is 287 and my class average is 95.67. So we see a more precise calculation of the class average in this example. So let's see how we went about introducing the floating point numbers and also introduce a couple of new features to you. Now, in the gradebook.cpp file, we have a couple of new features that we're including and using for the purpose of displaying the class average with 2 digits to the right of the decimal point. One of them is the so-called fixed stream manipulator, and basically we use this with cout to say when floating point numbers are displayed to ensure that the decimal point will be displayed. And the reason we do this is in C++, if by any chance you have a floating point number where the digits to the right of the decimal point are 0 or zeros, it does not display trailing zeros for that purpose. So if I had 72.0, it's going to display 72 by default. If you want to force it to display a decimal point, you can use the fixed stream manipulator. The other thing we're doing is including from the iomanip header, which is another standard library header. iomanip stands for Input-Output Manipulators. And in that header file are other stream manipulators, the so-called parameterized stream manipulators, the ones that actually require arguments to do their tasks. And one of those is the set precision stream manipulator, and its purpose is to specify exactly how many digits we want to the right of the decimal point. So if the result is 72.666666667 and you only want it to be 2 digits, you can set the precision to 2 and it will display 72.67 as the result. So let's take a look now at how we use these new features along with our new version of the determine class average method. Now, our member function, excuse me. As we had in the last program, we declare 4 variables that we're going to use: the total to store the total of all the grades, grade counter to keep track of the number of grades entered, grade to store each grade as it's entered, and in this case the double variable average, which will excuse me, which will store the average after we perform the calculation. Now, at line 58, as we did in the last program, we start initializing the variables total and grade counter. And again, it's important that these be initialized before we use them. Now, the total is set to 0 again, but the grade counter in this example is set to 0 rather than 1. And that's because we're using Sentinel controlled repetition. If in fact we don't enter any grades, we don't want the grade counter to be higher than 0 because we're going to use that to help us determine whether any grades have been entered and also to help prevent division by 0. So in this example, grade counter does not represent the grade that's about to be entered. It represents how many grades have been entered so far. We prompt the user to enter the grade or -1 to quit, and we read the grade in. Then we test the grade that was just entered to see if it's not equal to -1, and if so, in this while repetition statement, we perform the tasks of processing that grade and obtaining the next grade. And in C++, the syntax is the while keyword followed by a set of parentheses wrapped around the condition, and the set of curly braces define the body of the loop. The curly braces are only required if you have more than one statement in the body of the loop. So if it's a valid grade, i.e. it's not the value -1, we will add it to the total. We will add 1 to the grade counter and store the result in the grade counter, and then we'll prompt for and obtain the next grade from the user, or possibly the sentinel value. When we reach the closing curly brace, we go back to the condition, and if it's a valid grade, we process it. If it's the sentinel, we jump down to line 78. Now in lines 78 through 90 we have a little if-else statement here, and notice for the if part that we have multiple statements in the body, and therefore we have a set of curly braces, but for the else part we have a single statement in the body, and we chose not to use any curly braces here. Some programmers always use curly braces on every control statement, no matter how many statements they have in the body. That makes the code a little bit easier to modify later if they have to add statements to the body of a control statement, separately it just makes it clearer what's in the body of a control statement. So if I were to do that for the else part, I could put in my left curly brace and my right curly brace like this. So let me just go back to the way it was. Okay, so now in the if part, if the grade counter is not equal to 0, then I know that at least one grade was entered and I can calculate the class average. Otherwise, I will simply display no grades were entered. So let's look at the features inside the if statement now. At line 81, we're doing a new operator, or presenting a new operator. It's called the static cast operator. And let's explain why we're using this. So over on the right side here, we have the variable total, and we want to divide it by the variable grade counter. Now, total is an integer, as you can see but when I hover over the variable, and grade counter is also an integer, as you can see. So integers divided by integers in C++ and many other languages that are based in general on C++, those languages produce integer results when both of the operands are integers. And so if we want to calculate an average that has a floating point part, a part to the right of the decimal point, somehow we have to turn this operation into a floating point division. And in C, C++, Java, C#, JavaScript, all these different languages, when you have a floating point number divided by an integer, these languages automatically convert the integer to a floating point number and then perform a floating point arithmetic calculation. So what we're doing here is we're simply forcing the value of the total to be treated temporarily as a double value. So if the total is 287, what we're basically saying with this highlighted piece is treat that 287 for the purpose of line 81 as 287.0, which is a floating point number. And then I have a floating point number divided by an integer, and when I have a mixed expression like this, C++ automatically upgrades or converts the lower types, if you will, to the higher types. So integer is considered to be a lower type in the type hierarchy than double, and an integer can always be represented as a double, but the reverse is not true, because when you convert a double down to an integer, you lose data. So automatically the grade counter will be converted to a double as a result of the fact that total is temporarily being treated as a double. That will create a double divided by a double and produce a double result, which can then be assigned to our average variable. Now, the operator we're using to perform the conversion of the variable total, or the value of the variable total, temporarily to type double, is this so-called static cast operator, which is the keyword static underscore cast followed by a set of angle brackets containing the target data type, the data type to which we want to convert the value of the variable in parentheses. So what we get is a copy of the total. That copy is converted to type double. That double version of the total is then used to be divided by grade counter, and that performs the floating point calculation. So then at line 84, we display the number of grades that were entered and the total. And here at lines 86 and 87, we say class average is, and then we output the set precision with the number 2 as an argument. That's a stream manipulator, which says set the output stream so that all floating point numbers from this point forward will be displayed with 2 digits to the right of the decimal point maximum. And that means it could be 0, 1, or 2 digits to the right of the decimal point. But then we also output the fixed stream manipulator, and what this does is it forces the decimal point to appear, and when you combine these two as part of an output statement, what that does is it forces all floating point numbers to be displayed with precisely 2 digits to the right of the decimal point. So if it's 72.1, it will actually get displayed as 72.10. We then display the value of the average, and we output a new line and flush the buffer to display the final result.